Welcome back. In the last lecture, we discussed something about the syntax of modal logic, where we introduced various modal logical systems like K, T, D, S4, S5, etc., based on some of the characteristic axioms. So, in this lecture, we will be doing semantics of given semantics of modal logical systems like K, T, D, S4, and S5. And you have to note that till 1960s, logicians were continuously trying to they were proving theorems within these 5 axiomatic systems. Of course, there are many other modal logical systems which existed during that period of time. Their interest was only to prove theorems based on some kind of set of axioms, and the actual credit goes to Kripke, and just based on some kind of relational structures, he could come up with this idea that we can talk about the validity of a given formula, and he also introduced 4 levels of truth, that is truth with respect to a world, truth with respect to a frame, truth with respect to modal, and truth with respect to all kinds of Kripke models. So, in this lecture we will be talking about Kripke semantics, or you can call it possible worlds semantics for the modal logic. So, before that, what we have seen so far is this thing. So, we talked about modal logic is all about extensions of classical logic with these 2 operators. It stands for necessity and this stands for possibility. And in that context, all the tautologies of propositional logic are already there, and if you add these 2 things, possibility and necessity, plus this particular kind of axiom like F implies G implies necessity of F implies necessity of G, then this will become K, axiomatic system K, and which is due to Kripke himself, and this is considered to be the minimal modal logic. So, now this is considered to be the characteristic axiom for K. So, for D is nothing but it is K. Everywhere you will find this K in all the modal logical systems. So, it is not all the modal, in D you have K, together with that it has its own characteristic axiom. So, that is this thing, something is necessary implies that it is possible that phi. It does not imply that what necessary truth does not imply that something which is actually true. So, that is the case for T. So, in the case of T, it is D plus we have this characteristic axiom. So, this tells us that all the necessary truths are actually true as well, but this same kind of axiom may not apply here. You ought to follow the traffic rules implies that you actually follow the traffic rules. That need not have to be the case. You can always come up with an example where you ought to follow the traffic rules is true, but you may not actually follow the traffic rules. So, this may not apply in the case of deontic logic. So, now there are other things which most of the things are studied in the context of understanding the strict implication. The C.I. Lewis has come up with 5 different axiomatic systems in order to understand the strict implication. Unfortunately, the attention on strict implication has been diverted, and it has been diverted into proving some kind of theorems, etc. And then from 1960 onwards, 1960 to 1972, this is what we have discussed in the historical origins of modal logic. This is considered to be the classical era. So, in that it was dominated by some kind of relational structures. That is what we are going to do in this course, in this class. The relational structure is defined in this sense: M is equivalent to set of possible worlds and accessibility relation and the valuation function. So, now B is another axiomatic system which results in when you add this particular kind of characteristic axiom to T. Whatever is T is already there in B, and you have to add this particular kind of thing. So, that is, if something is actually true, and this implies that it is possible that phi has to be necessarily true. So, usually we have from phi you can derive possibility of phi. So, I am philosophy teacher, it means it implies that I could have been a philosophy teacher. So in the same way, from necessity of phi, you can derive phi, but you should note that you cannot this possibility of phi does not imply this one, something which is actually the case that phi. Suppose if I say that it is possible that it is raining outside, then it may not be actually, it is not actually true. So it may be possible that it is not raining also. So B has this particular characteristic axiom, and the other things are S4 and S5. S4 and S5 has these things. T is already having this axiomatic system T plus this one. It is necessary that phi. So why these other things are introduced? Because modal logics has been extended to deal with arguments which involves knowledge claims, etc. So this can be viewed as this thing. I know that something is the case implies that whatever is known to you is also known to you. If this necessity is viewed as knowledge operator, then you have to read it in that particular kind of format. In the same way, K T rule can be read like this: whatever is known to you have to be actually true. You cannot say that I know something and that is actually false. You cannot come across with a case where you know something but it is false. S5 has this thing again T. T means D plus this one. What is D? D is K plus this one. So this is T. Possibility of phi implies that it is possible that phi has to be necessary. So these are some of the most widely studied axiomatic systems in the modal logics, and each and every logic has resulted in to explain, for example, in the case of deontic logic, this takes care of the deontic logic D, and then say some other logical systems such as S5 for example, which takes care of epistemic logic. So if you draw a diagram, our diagram will appears to be like this. You start with the minimal modal logic K, and then it goes all the way up, and you have D, because this is an extension of K, so you have D, and then followed by that you have T. Your arrows are important here. So now from T add some more things, you will have B here, and in the other direction you have S4. Now these arrows are important. Now from S4 all the way up you end up with S5. This is the arrow that goes going like this. Now it goes like this. From B adding something, you move to S5. So now this is the syntactical kind of things that we already have. So now what Kripke has to say about these things? What did Kripke, what is the innovative ideas of Kripke? Why it is Kripke semantics is considered to be a revolution in the history of logic, particularly in the case of modal logics. So now let us talk a little bit about what exactly we mean by a Kripke modal. Before considering the Kripke modal is considered to be a triplet which consists of set of possible worlds W, and you have an accessibility relation with which you will be able to know in what way these possible worlds are related to each other, and then we need to know the access, that is the accessibility relation, and we have a valuation function which assigns some kind of values to the propositional variables that exist in your modal logical formula. So now before we begin, we need to start with the set of possible worlds. So this W, R and V is viewed as relational structure. So later it is viewed as some kind of directed graphs, etc. To start with, we need to begin with the possible worlds. I will be talking about the notion of possible worlds in a separate lecture, where I will be linking it with modal realism. But for time being, possible worlds, there are things that could have been different in different ways. So these are similar to the state description that are already mentioned by Rudolf Carnap, but Kripke used the metaphysical terminology of the 17th century philosopher Leibniz. Leibniz viewed that or argued that the world that God has created is considered to be one of the best possible worlds. So there are several worlds, and this world is considered, the world which we are inhabiting is considered to be the best possible world. That is also viewed as possible world, but it is considered to be the best possible world. And in that context, he proposed that the necessary truths are considered to be eternal truths, and for example, necessary truths are like 2 plus 2 is equal to 4. These are the truths which, that are considered to be true in all possible worlds, including the best possible worlds that we inhabit. So the idea has come from Leibniz notion of possible worlds, where he defined in this sense necessity of P means something is necessarily true means it is true in all possible worlds, and something is possibly true means it is true in only some possible worlds. Not only these possible worlds hold as long as the world exists, but also they would have held if God had created the world according to a different plan. So this is what is quoted from, this is what is mentioned in Leibniz, which is quoted by logician Mates. So what are some of the properties of these possible worlds? So it has more objects, events and individuals than the real ones. So you have to view these possible worlds. For example, let us take a simple example. Suppose if we take a snapshot of this room, that is considered to be the real world, assuming that that is the real world, and then you alter it a little bit from that snapshot, or you move one object from that thing, and the resulting one is going to be a possible world. It is not exactly same as the real world, but it is something different from the real world, but it is closer to the real world. So the possible world has more objects, events and individuals than the real one, such as, for example, cancer cure, or a bridge between the earth and the moon, or a third world war, etc. There are different possibilities which it can happen, or a 10 feet tall person, or it is considered to be a Mars expedition. It is possible that there will be Mars expedition, which is already the case, or Superman, etc. All these things are related to some objects. It can even have less objects also, like in this case, events and individuals, less objects, events and individuals than the real one, such as pyramids, no Gulf War, no Shakespeare, etc. It will be a very limited set of worlds. It can go in either way. Given anything, you will have more objects than the actual thing, or lesser objects than the actual thing. So it differs with respect to the properties. For example, in this case, Sydney Opera House is red, and I am a multimillionaire, etc. Or it differs with respect to relations. In this example, the Great Wall of China is located in the Middle East. So what I have been talking about is that a relational structure consists of possible worlds, and accessibility relation R, and the valuation function. So let us talk a little bit. I will be talking more about these possible worlds a little bit later, maybe in the next after a few lectures. So I will be talking about possible worlds and its relationship with modal realism. So accessibility relation is that not all possible worlds are accessible from a given possible world W. And a sentence of the form, let us say possibility of A is considered to be true in a world W only if there is at least one possible world which is accessible from the actual world to that particular kind of world. If that is not accessible to that one, then it is considered to be false. Similarly, a sentence of the form necessarily A is going to be true in a world W only if A is true in all accessible possible worlds. Suppose if you in your diagram it is like this. So these are some of the worlds that we have, W1 and W2, etc. and W3. So let us say you are talking about the truth value of some kind of modal sentences like this with respect to some kind of relational structure, that is what we are calling it as Kripke model, W, R and V. So without some set of words and accessible relation and valuation function, you cannot talk about Kripke model. So now necessity of P, for example, you have P here and P here, and then let us say possibility of P. So, let us say when necessity of P is going to be true in this world W1, any world W1. So, this you write it here like this, necessity of P which is true in a world W1. Necessity of P is true in a world W1, especially when whatever worlds this it has access to. So, this is the world W1 is accessible to W2, this is what you write, this is the way you write it, and here W1 is also accessible to W3. So, now in all the worlds this W1 is accessible to, in those worlds your P has to be true. If that is the case, then the necessity of P holds. For example, if you have a situation where you have like this, then in this world the world which is accessible from this is this one and this one. In this world P is true, but here it is false. In that case necessity of P does not hold. What about possibility of P? Possibility of P is defined in the sense that something is possible means at least in one possible world it is true. So, in this case at least in this one W1 is accessible to W2, and in W2 your P is true. But if you go to the other direction in this way, W1 is accessible to W3, but P is false there. Although it is false there, but for possibility of P, if at least one world exists where in that world your P is true, then this holds. So, this is the way you need to view the truth value of a given modal logical formula with respect to a world. You need to note that Kripke is talking about truth value of a given modal logical formula in different levels. First he talks about truth with respect to the worlds, and the second he talks about a frame. A frame consists of suppose if you in this W, R and V, if you take only W and R, you take only the set of possible worlds and the accessibility relation, and this is what is called as frame. And then if you take all the three things, it is considered to be a modal, and if it occurs in all kinds of models, which happens for the case of tautologies, then something is true in all Kripke models. So, now what is the accessibility relation? A sentence of the form possibility of A, which is A is true in a world W only if there is one possible world, at least one possible world where your A is true. Similarly, a sentence of the form necessity of A is going to be true only if A is true in all accessible possible worlds. Now, what about the valuation function? So, the valuation determines for atomic proposition that exist in a given modal logical formula that they are either true or false at a given possible world. So, this is the valuation that you are giving. P is true with respect to world W2, and here we do not have anything. So, this may turn out to be the case that this world may be accessible to itself. In that case your things will change, the value of these things will change. So, the valuation of P here in the world W3 is false. So, what all you require is that in order to talk about, so ultimately what we are trying to do is that in the case of syntactic tradition, that is a second era of modal logic, people were continuously, logicians were continuously trying to prove theorems, and of course all the theorems are considered to be valid formulas. So, Kripke talked about validity of a given modal logical formula in a totally innovative way. The innovative way is this thing, that truth with respect to possible worlds. That is why this possible world semantics has come into existence. So, we will be talking about more examples a little bit later, but let us talk more. Let us talk in some detail about some more details about Kripke's model. So, what is considered to be a frame with respect to Kripke model? A frame consists of set of possible worlds and accessibility relation, whose members are generally called possible worlds W and a binary relation R, which tells us which possible world is linked to what. If U and V are said to be possible worlds, U R V, that is what is accessibility relation, which tells us that U is accessible to V. So, if you write U first and then followed by that R and V, this means U is accessible to V. It is not the case that V is accessible to U. So, that means depending upon what logics you are talking about, this accessibility relation changes. So, in the case of epistemic logic, accessibility relation is viewed as some sort of indistinguishability relation. That we will not talk about it in this class, but you have to view this accessibility relation in a slightly different way. So, these are some of the standard definitions. A Kripke frame which is considered to be an order pair WR, which consists of non-empty set of worlds. You can have empty set of worlds also, but ideally speaking, you should have at least one world which should be accessible to the actual world. It happens only in the case of some kind of impossible worlds. Suppose if you say 2 plus 2 is equal to 5, you cannot come up with any possible world which is closer to 2 plus 2 is equal to 5. You cannot even imagine that one. That world has to be either impossible or empty world. So, always we take into consideration that a Kripke frame should consist of non-empty set of possible worlds, and you have an accessibility relation which is considered to be a cross product of various kinds of worlds that exist in your case, and the elements of W are considered to be possible worlds and R is considered to be accessibility relation. That is what is Kripke frame. Kripke structure or model is W, R and V. It is a triplet which consists of set of possible worlds, accessibility relation and the valuation function. So, there is a mapping from atoms, atomic sentences like P, Q's, R's, etc., and it generates some kind of values, either it is true or false. That means it assigns some kind of truth values to all prepositional letters in all kinds of words. Kripke model. The semantics for the basic modal logic was initially developed by Kripke, and there are several other logicians, Kainger, Jaakko Hintikka and all others during the time, that particular period of time, 1960s to 1970s. Who has come up with this idea first, we do not know. Everyone says that this is their own idea. So, it is debatable kind of thing whether Kripke has come up with this first or Kainger or Hintikka. Parallelly all of them are working on similar kind of idea. So, if you see the history of logic into consideration, it appears to be the case. So, a model, a Kripke model is considered to be in propositional logic is simply a valuation function assigning truth values to the set of atoms. So, now you can talk about Kripke models even in the context of propositional logic also. So, a relational structure, that is what was given utmost importance till 1972s, etc., excessive emphasis on this relational structure. The relational structure again is a triplet which consists of non-empty set of worlds W, accessibility relation R and V. V is considered to be valuation function assigning truth values to the atomic sentences that exist in your given formula. Suppose if I write V P W, that means P is true in a world W that is considered to be true, and formally valuation function is defined as a cross product of S and W. S into W implies it has to take some kind of value T R F. So, that atomic sentence P, it assigns some kind of values to the atomic sentences that exist in your modal logical formula. That thing has to be either true or false. So, what all you need to know the validity of a given formula boils down to a simple we need a simple Kripke has come up with a simple diagrammatic representation with which you can express the validity of a given modal logical formula. What all you need is that non-empty set of worlds, and you have accessibility relation. It tells us how these possible worlds are connected to each other, and then you should know when where a given atomic formula that exists in your modal logical formula is true, in which world it is true. So, truth in a modal, it is like this. If you take WRV to be a Kripke structure, a relational structure, modal, they are same. This relation V is extended to some arbitrary kind of formulas, and this is like this. Suppose if you take a set of worlds gamma, set of worlds W, which includes W1, W2, 3, etc. The set which consists they are in this set gamma. Then suppose if you say X is X is not a logical, not X is a logical consequence of gamma, which is written as gamma does not belong to x means x is true in gamma. X and y is a logical consequence of gamma only when both are considered to be logical consequences when they are taken individually. X has to be logical consequence of gamma, even y is also logical consequence of gamma. These are all the things which are already there in the case of propositional logic, and in our context we need to come up with the meaning of this modal logical formula. Here you need to note that meaning of a formula means giving truth conditions. So this is the truth condition, that is why we are calling it semantics. So necessity of x is considered to be logical consequence in your formal system or logical system. Gamma, which it includes set of formulas, if and only if for every v belongs to the set of worlds w, and you have an accessibility relation, u is accessible to v, and in that world v your x has to be true. So this should happen for any v, any indexical letter v. So any world which is accessible from the actual world, in all those worlds your formula has to be that x has to be true. And possibility of x is defined in this sense. Possibility of x is going to be true if and only if for some v belongs to w and this u has to be accessible to v, and in that possible world v your x has to be true. So in the next class we will be talking about some more we will be talking about the Kripke models with some more examples. So the examples will simplify our understanding of or the usage of Kripke models. So the idea here is that this proving theorems etc. or showing that a given formula is valid etc. are all simplified much better in the Kripke semantics, and then we can simply we can draw the diagram, and then by seeing the diagram itself you can make out whether a given formula holds in a given world, or it holds in a given frame, or it holds in the Kripke model. So we will continue with more examples on Kripke semantics in the next class. Thanks. Thank you very much.